Hello everyone, this is Vani from R.M.K College of Engineering and Technology. In this video, we are going to discuss about convolution encoding, which is one of the techniques in error control coding. So, the convolution encoder is called as bit by bit coder. Actually, we have two types of coding techniques. One is linear block code, where at a time block of codes are accessed in order to generate a code word. But in convolution encoder, it is bit by bit operation using flip-flop. So it does not require any memory. If we see in linear block code, as we have to process at a time n block of bits, memory is required. But in convolution encoder, it is bit by bit coder, so memory is not required. So in telecommunication, a convolution code is a type of forward error correcting code, which is used to improve the reliability of communication system. So convolution codes were um, introduced in 1955 by Peter Elias. A message is convoluted and transmitted into the noisy channel. So at the transmitter, it is convoluted, and at the receiver, the redundant bits which were added due to convolution are extracted in order to find out the error position and correct the errors. So this convolution operation encodes some redundant information into the transmitting signal, thereby improving the data capacity of the channel. So it's a finite state machine processing information where the information is processed in serial manner, and convolution encoding of data is accomplished using shift register when we are operating serially. So we use shift register, and the modulo 2 addition is performed here. So a shift register is a chain of flip-flop wherein the output of nth flip-flop is tied with the input of n plus 1 flip-flop. So it's a kind of chain. So every time the active edge of the clock occurs, the input to the flip-flop is clocked through to the output, and thus the data is shifted over one stage. So this is the basic operation of shift register. And in 1967, Andrew Witterby determined that the convolution codes could be maximum likelihood decoded with reasonable complexity using a time invariant trellis based decoder, which is called as Viterbi algorithm. So for convolution encoding, we use Viterbi algorithm for decoding. So the parameters involved in convolution encoder design are n, k, k, where small k is the number of input bits. Generally at a time we are processing only one bit, so it is 1. And small n is the number of output bits, and capital K is the number of memory registers, how many we are using. So the dimension of the code normally we represent as n, k. So for every message bit, total number of outputs are generated. And we define code rate. The unit of code rate is bits per symbol, and it is nothing but small k by n. And it is a measure of the efficiency of the code. How much efficient the convolution code is can be found out using code rate. So one of the other parameter is constraint length, where it is defined as the number of shift over which a single message bit can influence the encoder output. So the encoder memory, a shift register of size K or L, is the constraint length. So number of shift register is equal to the constraint length. So convolution encoder can be represented in 4 ways, either in kind of generator representation or state diagram representation, even in terms of tree diagram representation and trellis diagram representation. So here one of the simplest convolution encoder is shown, where the code rate is 1 by 3 because the number of outputs is 3n, and at a time 1 bit is processed, so 1 by 3. With constraint length of 3 means we are having 3 flip-flops here, and generator polynomials given as G1, G2, G3. So here all 3 are present, so we represent as M1, M0, M with the suffix -1. And here first one is 0, 1 comma 1, so we write as M0, M minus 1. And here if you see 101, so M1 is present. M0 is not there because of 0 here, and M with respect to -1. That is with suffix -1. So if we see here, the input bit coming here, it was shifted, getting shifted with 3 levels, M1, M0, M with suffix -1. And we have 3 outputs, N1, N2, N3. As represented here, N1 contains all the 3 terms. So we get the link from all 3. M1, M0, M with suffix -1. N2 has from M0 and M suffix -1. So we take from this 2, which is N2. And N3 contains M1 and M with suffix -1. So we take it M1, M suffix -1, and N3 is generated. So this is the way how the convolution encoders are represented and designed. Thank you.